Hello everyone, my name is Maciej Szewczyk and on this channel you will learn how to solder and understand the principles of electronics. Today we will complete our exploration of LEDs, but most importantly we will learn what an SMD component is, how to read the codes marked on them and discover the secret of soldering these components. I remind you that this entire lesson is also in article form on our website voltnova-labs.com. I encourage everyone to visit because there's a special simulator there that will help you understand electronics more easily. Remember that our mission is to teach you electronics and soldering. If you are eager to join the Voltnova community and want to learn electronics and soldering with a special home laboratory, I also invite you to visit the website at voltnova-labs.com. This lesson is more practical, but that's what electronics enthusiasts love. First, we need to understand what SMD components are. SMD components are a type of electronic component package and soldering method. SMD stands for Surface Mount Device, meaning components soldered directly to the surface. This means we soldered them on one side or the other directly onto the printed circuit board. They differ from THT through hole technology, components primarily in size and soldering method. This course covers SMD soldering techniques and these components because a significant portion of electronic devices on the market use SMD components, making them essential knowledge. Resistors, LEDs, capacitors, fuses, and integrated circuits, essentially all electronic components, can come in SMD packages. Passive components like resistors and LEDs that have two terminals come in rectangular shapes. Their package names depend on the component size. The size designations of these packages aren't measured in millimeters but in mils. 1 mil equals 1,000 of an inch. For example, a 1206 package measures 220 mils by 60 mils. Converting this, it's quite small, but among SMD packages, it's actually quite large. There are also 0805, 0603, 0402 and even smaller packages, where working without a microscope becomes nearly impossible. In the lesson 5 back, we have LEDs and a resistor in 1206 packages, which can be comfortably soldered without magnetification. Worth mentioning, lesson 6 includes a tantalum capacitor in an SMD-A package. SMD packages can also use letter designations from A to E, as well as the letter V. Let's also mention, for those unfamiliar, what integrated circuit is. An integrated circuit is an electronic component containing transistors, diodes, resistors, capacitors, and other components all within a single package. There are numerous types of AC packages, but our kit doesn't include any at this stage. Let's learn how to decode these codes. Take the resistor from our kit marked 621. The method is simple. The last digit indicates how many zeros to add to the result. 6, 2, and 1. So we add 1 zero, giving a final resistance value of 620 ohms. Another example, 183. This means 18 with 3 zeros added. 18,000 ohms equals 18k ohms. 4-digit codes work exactly the same way. The last digit still indicates the number of zeros. Example, 3502. This gives us 350 with 2 zeros. 35,000 ohms equals 35k ohms. Codes with the letter R indicates a decimal point. Example, R020. This means 0.020 ohms equals 20 milliohms. Example, 2R2. This means 2.2 ohms. Letter suffix codes. Unfortunately, it gets more complex. Some resistors have a ladder at the end, which requires a special lookup table to decode. The ladder acts as a multiplier, example 23C. Using the lookup table, we find 169 with a multiplier of 100. This resistor would have a value of 16,900 ohms. Important note, these decoding methods don't always work universally because different manufacturers introduce their own coding systems. Keep this in mind when working with components from various sources. As covered in the previous lesson, LEDs must be soldered into circuits with correct polarity. Our SMD LEDs are no exception. Identifying polarity on SMD LEDs is straightforward. Our LEDs have green dots on one side marking the cathode negative terminal. If you turn the LED over, you will see its schematic symbol showing the direction of current flow, which helps identify the anode and the cathode. Before we learn to solder SMD components, let's cover some theory and calculate what resistor is needed to supply proper current to 3 LEDs. Suppose we want to supply a single LED with 10 mA current. Remember from Kirchhoff's first law that current divides through the circuit branches, so the main current must be 30 milliamps, correct? We know the current and the voltage drop across the LEDs is 2 volts because they are red. The voltage will divide into two parts because these 3 LEDs are connected in parallel. R equals 9 volts minus 2 volts divided by 30 milliamps equals 233 ohms. The resistor is calculated, but you need to know something very important. I remind you of the information covered in lesson 2, specifically the rated power of resistors. Components in 1206 packages most commonly have a power rating of 250 milliwatts. Let's check if this resistor can handle the current flowing through it. The power formula is power equals U multiplied by I. 7 volts multiplied by 30 milliamps equals 210 milliwatts. Honestly, this value is close to the maximum power rating of this component, so it's better to reduce the current value. The resistor included in the lesson is 620 ohms, as that's the only value provided. Let's check what current value it will limit to. I equals 7 volts divided by 620 ohms equals 11.2 milliamps. Dividing this into 3 equal parts gives us 3.7 milliamps per branch. Summing up this information, each LED will be supplied with 3.7 milliamps. There's no point calculating the power dissipation because we know it's far below 250 milliwatts, but you can calculate it yourself to be certain. Remember that SMD LEDs don't require such high current. Let's now move to the workshop and learn how to solder SMD components. Now for the best part of this lesson, practice, something every electronics enthusiast loves, especially when something will light up. The SMD components in 1206 packages from our lesson 5 kit aren't actually that small, as they can be much smaller. If you have ever looked at the motherboard, for example, the components there are truly microscopic. Remember that SMD package size relates to the power the component can handle. For this course, 1206 packages were chosen so you won't have problems soldering the components, and the working with our complete electronics kit will be pure enjoyment. In the future, we will learn to solder SMD integrated circuits where there can be 16, 46 or even 144 or more pins. The soldering technique for those is somewhat different than for passive components like resistors or LEDs. If you are comfortable soldering through-hole components, SMD soldering won't cause you any problems. The soldering technique and temperature settings are nearly the same. Temperature around 340 degrees Celsius, flux, solder, but additionally you need copper braid and tweezers. Flux must be in syringe. Tweezers are needed to hold the component being soldered and position it so it's attached evenly and flat. Remember not to stress or be afraid. This is seriously much easier than soldering TMC components. Before we proceed with soldering, let me show you the soldering tip I will be using. As you can see, it's flat, so it covers the entire solder path of the components being soldered. Heat transfers to the resistor without problem. If we had a tip that was too narrow, the tip would cool down quickly and we would have soldering problems. First step, turn on the soldering iron. As I mentioned, I set it to 340 degrees, but you can start there and adjust to see what happens at the temperature versus another. Don't be afraid to change temperatures. Second step, apply a small amount of flux to the solder pads. You can even apply it to all the pads to get that out of the way. First step, hit the solder pad and introduce a small amount of solder. This is truly a small amount, but if you add too much, don't worry, I will show you how to deal with that shortly. This is what a solder pad with solder looks like. Fourth step, take the tweezers and pick up the resistor. Hit the solder again, bring the component to the tip. Slowly position the resistor without stress. This process can take up to 20 seconds. Release the tip and done. The first terminal is soldered. If you are not satisfied with the result, you can easily apply a bit more flux and reposition the resistor. It's important that the resistor is soldered with the markings facing up. Next step, solder the second terminal. Flux was already applied earlier. That's left is to touch the tip to the terminal and add a small amount of solder. And as you can see, it's not difficult at all. Remember to let the solder flow nicely to create a concave joint, a small mount. This is what a properly soldered component looks like. Notice there isn't really much solder. There's no dome or ball. The solder flows nicely from top to the bottom, from the terminal to the soldered pad. Now I will add a bit more solder to show you how to deal with this. We now have what you could call a good solder joint because the component is soldered and fulfills function. But it doesn't look good at all. Now copper braid comes into play and it can easily remove this excess. So we apply a bit of flux, hit the braid and touch it to the excess solder. The solder should transfer onto the braid automatically. If you are having problems with this, increase the temperature to 360 or 370 degrees. The resistor is soldered, so we have 3 red LEDs left to solder. You can do this one after another rather than soldering each completely separately. Solder one part from each LED having applied flux beforehand. Here's important information. As you already know, diodes have polarity, so they must be soldered according to that polarity. On the component, you can see a green dot and it marks the cathode negative terminal. On the reverse side, you can also see a triangle which represents the same triangle as in the schematic symbol. The soldering principle is literally the same. We hit the pads again and place the first element, now the second element and third element. Solder the remaining terminals and done. And as you can see, it's not difficult at all, right? Remember that you can modify the position of these components if you add too much solder or place them incorrectly. One note, don't keep the tip on the pad for too long, meaning for a minute or two, because the pad might simply lift off the board. Since we are in the workshop, after cleaning the PCB, we will measure the voltages present in this circuit. Current flows from our battery at a value defined by our resistor. So it's 11.1 milliamps for us and divides into 3 branches, meaning the 3 diodes. Here you can clearly see that because the diodes are in parallel, the voltage divided into 2 parts, the resistor which has this voltage drop and the diodes which have this voltage drop. Current can of course be calculated using Ohm's law. That's everything in the workshop. We have learned to identify SMD components, how to solder them, and verified how to power multiply LEDs. I will mention that the smaller the component, the lower its power rating. So when selecting a resistor or other component, you must remember and above all calculate to verify that everything will be compatible. I hope everything I explained was easy and above all interesting. If you are uncertain about any information, remember to write a comment. Buy the Complete Electronics Kit to learn electronics in an easy and interesting way. Subscribe and like, and of course don't forget the bell. Thanks for watching. See you!